This is our first video for Unit 3, and we will be looking at finding intercepts and graphing from standard form. So to find x-intercept, we are going to cover up the y value and solve for x, or I should say the y term, and solve for x. To find y-intercepts, we will cover up the x and we will solve for y. So here's an example. We have 2x plus 3y equals 6. So what we have is a linear equation in standard form. So what we're going to do first is find the x-intercept. In order to find the x-intercept, what we're going to do is cover up the y. So I'll just cover up the y here, and then we have the equation 2x equals 6. So let me go ahead and do that down here. So we take 2x plus 3y equals 6. And what we're going to do is we're just going to cover up the 3y, and that leaves us 2x equals 6. Divide both sides by 2. And we find that x equals 3. That's for the x-intercept. For the y-intercept, we have our 2x plus 3y equals 6. And in this case, we're going to cover up the x term, and we'll be left with 3y equals 6. Divide both sides by 3, and we have y equals 2. Now, why is it okay for us to simply cover up something? Because in order to be an x-intercept, you must be on the x-axis. The value of y on the x-axis is simply 0. So if I replaced y with a 0, 3 times 0 is just 0. This whole term becomes 0, and that's why we end up with 2x equals 6. For the y-intercept, the reason that I can just cover up the x term is that along the y-axis, the value of x here is 0. So if I replace the x with a 0, 2 times 0 is just 0, and then we're left with just the 3y equals 6. So the reason that we can do this is because of the values of the other term on that axis in particular. So let's go ahead and figure out how to graph. Now that I have 2 points, I have my x-intercept and I have my y-intercept here. I'm going to go ahead and graph those points. I'm going to graph the point 3, 0. So I start at the origin, I go to the right 3, I don't go up any because that's what 0 means. And here is my x-intercept. I'm going to do the same thing with the y-intercept. My x value is 0. I don't go left or right any at all. I just go up 2 places. And here is my y-intercept. Please remember at any time to pause if you need to. Okay, so now that I have 2 points, I can connect those into a line. You can use your ID as a straight edge to help you with these. I'm just going to connect these 2 points, my x-intercept here and my y-intercept, and there I have my line. So let's look at some more examples on the inside of this set of notes. So here we have practice. So I'm going to first find my x-intercept. This means y is equal to 0. So that means I cover up the y, or the y term. So I have 4x plus 2y equals negative 6. Cover up the y term, so I have 4x equals negative 6, divide both sides by 4. And what I'm going to have here is an improper fraction, negative 6 over 4, that will reduce to negative 3 over 2. So my x-intercept is going to be negative 3/2. For my y-intercept, I'm going to need to remember that that means where x is 0. So I cover up the x term. So I have 4x plus 2y equals negative 6. I'm going to cover up the x term because that x is 0 and that term is going to disappear. Then I simply divide both sides by 2 and I get y equals negative 3. So the ordered pair here is x is 0, y is negative 3. And then the ordered pair up here was negative 3 over 2, 0. So what I'm going to do now is count on the x-axis to the left 3/2. So here's 0, here's 1/2, here's 1, here's 1, which is 2/2, and then here's my negative 3/2. And if I don't like that, what I can do is change the way that I count on the x-axis. So I can count by halves. There's 1/2, 2/2, 3/2, 4/2. Do the same thing on the negative side. Negative 1/2, negative 1, negative 3/2, negative 2. So I'm going to do that to make my life easier. So x is going to be equaling negative 3/2. On the y-axis, I'll go ahead and count by ones. Here's negative 1, negative 2, negative 3. So my y-intercept is down here where the y value is negative 3. And then I simply connect these 2 points. And I have graphed the linear equation 4x plus 2y equals negative 6. Okay, in this second example, we have negative 2x plus 4y equals negative 24. So for the x-intercept, again, y is going to equal 0, so we're going to get negative 2x equals negative 24. Solve for x. So x is going to equal positive 12. So this is the ordered pair 12, 0. Then for my y-intercept, I'm going to let x equal 0 because that's what happens along the y-axis. The value of x is always our 0. So we're going to end up with 4y equals negative 24 because the x term will simply disappear. And then we have the ordered pair 0, negative 6 for the y-intercept. Now if you'll notice this graph, what we have is it counts 1, 2, 3, 4, 5. If we just count by ones, we get to positive 5, negative 5. Positive 5, negative 5, and that's not going to work. If I count by 2's on the x-axis, 2, 4, 6, 8, 10, I can't get to 12. I need to get to 12. So what I'm going to do here then is count by 3's. So this will be 3, 6, 9, 12, 15, and then I can put my x-intercept at 12, 0. So on this side, it's going to be negative 3, negative 6, negative 9, negative 12, negative 15, just to label that. From there, I need to also look at my y-axis, and I couldn't count by ones there. And just to be on the consistent side, I'm going to go ahead and count by 3's here. 3, 6, 9, 12, 15. Down here, negative 3, negative 6, negative 9, negative 12, negative 15. So the y intercept is at -6, so that's where y is equal to -6 and x is equal to 0. And here we have our 2 points. So now I'm just going to connect those 2 intercepts so that I can quickly graph my line. Remember, on your lines you put an arrow at either end to show that they continue on. Okay, the next side we have a word problem. It says identify the x and y intercept. What does the x-intercept mean? And what does the y-intercept mean? And so let's go ahead and look at this information here. We have this graph that is telling us that it's about draining a pool. And we have volume or gallons over here. Looks like it counts by 2,000. So 2,000 gallons, 4,000 gallons, 6,000, 8,000, 10,000, and 12,000 gallons. And this is time in hours. So this is 0 hours, 2, 4, 6, 8, 10, 12, and 14 hours. My x-intercept occurs right here. Here's my x-intercept. And that order pair is 14, 0. My y-intercept is where this graph hits the y-axis. That hits here at 10,000, so x is 0 and y is 10,000. So what does this x-intercept mean? It means it took 14 hours to drain the pool. Because this is the point at which the number of gallons in the pool is 0, and it took 14 hours for the number of gallons to get to 0. What does the y-intercept represent? The y-intercept represents the initial volume of the pool. So the initial volume of the pool, it started out with 10,000 gallons because before we've done any draining, we measured 10,000 gallons in there. And after 14 hours, we have no more water left in the pool. So that's what the x and y intercepts represent for this particular example. Okay, problem number 4, they give us a table of values. This time is our x, so let's go ahead and label that x. This is our x, this is our y. We need to identify our x-intercept and our y-intercept. Our x-intercept is when y is equal to 0. So we go down here. Here's where y is equal to 0. So here is our x-intercept. That occurs when x is equal to 4 and y is equal to 0. So after 4 hours, there's no more distance. For the y-intercept, that is when x is equal to 0. And here is our y-intercept, and that is at 248 miles. Now, they don't give us a whole lot of other information, just that x represents time and y represents distance. So it looks like we had some distance that needed to be traveled. And so the x-intercept, it represents the time it took, which in this case was 4 hours. We'll just say to complete our journey. We had a journey of 248 miles to cover, and it took us 4 hours to cover it. What does the y-intercept represent? It represents the initial number of miles to cover or to journey. Okay, so the y-intercept represents the initial number of miles that we needed to go. The x-intercept represents the amount of time it took to go those miles. And this is it for the notes for standard form. So what you have is how to find intercepts using the cover-up method, where if you're finding the x-intercept, you cover up the y, and if you're finding the y-intercept, you cover up the x. And this was the detail on that. And then you use those 2 points, your x-intercept and y-intercept, and connect them to graph your line. We had 2 more examples on the inside of finding x-intercepts and y-intercepts and using those to graph. Same thing on this one, and here we had to count our graph by 3s. Up here we counted the x by halves and the intercepts by 1. Then we had 2 examples of identifying what x and y intercepts mean in context of either a given graph or a given table of values.